Well, hello there, geometry students. You've caught me in the middle of my afternoon snack, having a little bit of my free 100s in my mug. Let's see what's inside. Oh, whoops. There's nothing inside. If you haven't figured it out by now, there are no free 100s. But you can earn them here in my geometry class. All right. Today's notes are on changing dimensions with surface area and volume. We went over some of the stuff in class, and some of you guys were tracking with me. You got these relationships pretty down pat. I've kind of hinted at them. We've been talking about them since we've had changing dimensions of just regular area. So let's get started. The key concept that you must have is that if the scale factor of two similar solids is given to me as A over B, then the ratio of their surface areas will be that A over B, but square each piece. A squared over B squared. Then the ratio of their volumes will be A cubed over B cubed. So whatever the ratio is, you can either square it to get the ratio of the areas or cube it to get the ratio of their volumes. So here's an example. We're going to determine if the rectangular prisms are similar, and if so, we'll find the ratio, surface area, and volume ratios as well. Okay, so to determine if these rectangular prisms are similar, we're going to need to compare their corresponding pieces. So I've got 3 and 6. Okay, is 3 over 6 the same thing down here? I've got 3 and 6. Well, yes, those are the same. And then my last pieces, I've got 2 and 4. So what I've done here is I've matched up the corresponding dimensions. And if all those are the same, then these rectangular prisms are similar. Those all equal 1/2. So yes, this is similar, and that is then the ratio is 1/2. Okay, then I can find their surface area ratio by using my key concept up top there. Take the 1/2 and square it. It's going to square both pieces. So 1 squared is 1, 2 squared is 4. So the surface area ratio is 1/4. And to get the volume ratio, I take my 1/2 and I cube it, which 1 squared cubed is 1. 2 cubed is 8, not 6. Don't fall into that trap. Okay, 2 times 2 times 2 is 8. So the ratio of my volume is 1/8. Okay, hopefully that makes sense. Next, if it doesn't make sense, please pause the video and grasp that first before we keep going. Example 2, find the scale factor of 2 cubes with volumes of 729 cubic centimeters and 1,331 cubic centimeters. Okay, so this gives me my 2 volumes, so I can make a ratio of that, and this will be the ratio of their volumes. Okay, so A cubed over B cubed would be given to me 729 over 1331. It wants me to find my scale factor, which is just A over B. So, as we've discussed in class as well, if I have something that's cubed, I want to undo the cube. That would be with the cube root. So if I take the cube root of both sides, that's going to get me then, the cube root of A cubed over B cubed is just A over B. So I need to take the cube root of 729 over 1331. If you have a T84 or a T83, hit math, go to the cube root. You can put in a fraction here, or you can do this without fractions. Most of you guys like the fractions piece. So 729 over 1331. We like it because it gives our answer in a fraction as well. So the cube root of that is 9/11. That is then my scale factor of the two figures. All right, last example. The lateral areas of two similar paint cans are 225 inches squared and 160 inches squared. The volume of the smaller can is given to me as 128 cubic inches. What is the volume of the other, the larger paint can? All right, so let's think about what they've given to us. They've given me the ratio of their areas. It says lateral areas, which is just the label of these paint cans, but that would still be the areas. Okay, so A squared over B squared in this case is given to me as 250 over 160. All right, and so in this ratio here, they've given me this one. I need to identify the volume ratio to find my new volume of the larger paint can, but I cannot go straight from the surface area ratio to the volume ratio. I can go from the surface area ratio back to my original ratio, and then cube that to get my ratio of the volumes. So that's what I'm going to do. First, I need to find out what my just original ratio of the two similar figures are. So I'm going to take the square root of both sides. And if you don't have a T84 or 83, this is how you would do it. Okay, you should have a square root button, and then I'm just going to do 250 divided by 160, And if you put that in parentheses, it'll do the same thing. That'll give me 1.25. And if you don't know what that fraction is, hit the fraction menu. So we get 5/4 is my original scale factor. Okay, I cannot use that to find the new volume yet. Like I said, I need to find out what is my a cubed over b cubed. So I've got to take the 5/4 and cube it. So back over here, take the cube of that. That's going to give me 125 over 64. And as we know, 5 cubed is 125 and 4 cubed is 64. So this is the ratio then of my volumes. I can use that with my smaller volume to find the bigger volume. All right? So we do that. This is proportional, so I'm going to set up a proportion. 125 over 64 will be equal to the 128 is going to go on the bottom, since that the bottom number is my smaller number, and I want to find the bigger number. All right? We've got a proportion, so I can cross multiply here. 64 times x. And then 125 times 128 is 16,000. Divide by 64 to get my new volume of 250 inches cubed. Let me go back one step real quick. We've done proportions enough. Hopefully you may know this. There's a shortcut to this, kind of. If I've got my denominator 128, I could just simply multiply both sides by 128. And 128 over 128 leaves me with just x. And so if I multiply this side, 125 over 64, just times 128, there it gives me my 250 exactly. So a shortcut in solving proportions, that's only if we have a singular variable in the numerator there. If we don't, if the if the variable's in the denominator, we can't do that process. Then we have to cross multiply and divide as normal. But we can also just always cross multiply and divide. All right, I hope you got that last example. If it didn't make sense, please pause the video, look at this work. Realize that we first had to find the scale factor of the figures first, then cube it to get my volume scale factor, my volume ratio, then use that in a proportion to find my new volume. All right, thank you so much, guys. Have a great day.